We are going to learn about solving systems of equations by elimination. The goal of systems of equations is to solve for two unknown variables, and we do this by canceling one variable to find the other variable. Hence, we eliminate one variable to find the other variable. So let's say we have the problem 2x plus y equals 6 and negative 2x plus 3y equals 2. And I'm going to put a 1 next to this equation and a 2 next to this equation so that it will be easier to communicate which equation I am referring to. We have to get rid of the x's or the y's to solve this problem. And we can do it either way, and we can get the right answer. So I'm going to cancel the x's. So I will add the two equations. I will add 2x plus y equals 6 and negative 2x plus 3y equals 2. 2x plus negative 2x equals 0. Y plus 3y equals 4y. 6 plus 2 equals 8. So we have 4y equals 8. Then we have to isolate y since we want to find y. So we will divide both sides by 4 and we will get y equals 2. Then we will put the value of y, which is 2, back into the original equation. We can put it in equation 1 or we can put it back in equation 2. I'll put y equals 2 inside the first equation, which is 2x plus y equals 6. So we will get 2x plus 2 equals 6. We subtract by 2 on both sides to get 2x equals 4. Then we divide by 2 on both sides to get x equals 2. We got x equals 2 and y equals 2. We can check our work. Let's plug x equals 2 and y equals 2 back in equation 1 and equation 2. So equation 1 is 2x plus y equals 6. When we substitute x equals 2 and y equals 2 in it, we get 2 times 2 plus 2 equals 6. And I put a question mark above the equal sign because we don't know if it's correct just yet. Then we get 4 plus 2 equals 6, and we get 6 equals 6. This is correct. Let's also plug x equals 2 and y equals 2 in the second equation. So equation 2 is negative 2x plus 3y equals 2. When we substitute x equals 2 and y equals 2 in it, we get negative 2 times 2 plus 3 times 2 equals 2. This becomes negative 4 plus 6 equals 2. And this is 2 equals 2, which is correct. Therefore, x equals 2 and y equals 2 are the correct answers. Let's try another example. Let's say we have the problem x minus 2y equals 5 and 3x plus 4y equals 10. I'm going to put a 1 next to this equation and a 2 next to this equation. We have to either get rid of the x terms or the y terms to solve this problem. And we can do either way to get the right answer. Since we got rid of the x terms in the last problem, we will eliminate the y terms for this problem. But how do we eliminate them? In equation 1, the y term is negative 2y, and in equation 2, the y term is positive 4y. To eliminate the y term, we will multiply the first equation by 2, so that the y term will become negative 4y, and we will be able to eliminate the y terms. So we will multiply the first equation by 2 to get 2x minus 4y equals 10. Remember that you can multiply the equation by anything and keep the value of the equation as long as you multiply by the same number on both sides of the equal sign. And we have the second equation as well, which is 3x plus 4y equals 10. Then, we will add the equations together to get rid of the y term. 2x plus 3x equals 5x. Negative 4y plus 4y is 0. And 10 plus 10 equals 20. We get 5x equals 20. We have eliminated the y term. Now, we will be solving for x by dividing by 5 on both sides. We will get x equals 4. So we got the x term. Now we can put it in any equation above to find the y term. Since we used the first equation in the first problem, we can use the second equation in this problem. So let's plug x equals 4 into the second equation, which is 3x plus 4y equals 10. So we get 3 times 4 plus 4y equals 10. We get 12 plus 4y equals 10. When we subtract by 12 from both sides, we get 4y equals negative 2. When we divide by 4 on both sides to isolate and solve for y, we get y equals negative 2 over 4. Hence, y equals negative 1 over 2. So we have x equals 4 and y equals negative 1/2. We can check our work to see if we got the correct answers. We check our work by putting the x and y values we got back into the original two equations. So let's plug x equals 4 and y equals negative 1/2 back into equation 1, which is x minus 2y equals 5. We get 4 minus 2 times negative 1/2 equals 5. Negative 2 times negative 1/2 is positive 1, so we get 4 plus 1 equals 5. We get 5 equals 5, which is correct. So let's plug x equals 4 and y equals negative 1/2 back into the second equation, which is 3x plus 4y equals 10. We get 3 times 4 plus 4 times negative 1/2 equals 10. We get 12 minus 4 over 2 equals 10. This equals 12 minus 2, which equals 10. And we get 10 equals 10, which is correct. Therefore, x equals 4 and y equals negative 1/2 is the correct answer. Let's try another example. Let's say we have the problem 2x plus y equals 3 and 4x plus 2y equals negative 1. I'll put a 1 next to this equation and a 2 next to this equation. We have to get rid of either the x's or the y's to solve this problem. So let's cancel the x terms. So in order for the x terms to cancel, we have to multiply the first equation by 2. We then get 4x plus 2y equals 6. And we have the second equation, 4x plus 2y equals negative 1. So in order for the x terms to cancel, we have to subtract the two equations. 4x minus 4x is 0. 2y minus 2y is 0. And 6 minus negative 1 equals 7. What you'll get is 0 equals 7. Now this is interesting. While in the process to cancel the x term, the y term got cancelled as well. Since 0 does not equal 7, there is no solution to this problem. There are no x or y values that satisfy both of these equations. The answer is that there is no solution. Let's try another example. Let's say we have the problem 3x plus 3y equals 9 and x plus y equals 3. I'll put a 1 next to this equation and a 2 next to this equation. We have to eliminate either the x term or the y term to solve this problem. Since we canceled the x terms in the last problem, let's cancel the y terms in this problem. So in order for the y terms to cancel, we have to multiply the second equation by 3. We then get 3x plus 3y equals 9. And we have the first equation, which is 3x plus 3y equals 9. Notice that these are the exact same equations. So in order for the y terms to cancel, we have to subtract the two equations. 3x minus 3x is 0. 3y minus 3y is 0. And 9 minus 9 equals 0. We get 0 equals 0. This is also interesting. Just like the last problem we did, while in the process to cancel the y term, the x term got canceled as well. However, this problem is different than the last problem. In the last problem, we got 0 equals 7, and since 0 does not equal 7, there was no solution. In this problem, we got 0 equals 0, and since 0 does equal 0, we have infinite number of solutions for these equations.